Hello, everyone. Thank you for joining us for our webinar today. My name is Erbil Kop. I'm working at CEF as the onboarding manager for the Context Broker, which is why we're here today with our technical experts to go through a very diverse agenda on the technical points. Before getting underway, I would like to just remind you a couple of things. This is an interactive session and you're mostly following us from our Slido page. Please feel free to use the Q&A at any point and post anonymously. That way we will have no issue of bringing your feed into and the question into the live feed. And I would like to also remind you that this webinar is recorded, and along with the slides that you're seeing right now, it will be shared on the event registration page as soon as possible after the event. I would like also to remind you that there will be in case of any technical issue and the feed stopping, please remain on the page. We will make our utmost to establish the connection as fast as humanly possible. So we have a packed agenda, as you can see. Today I will be doing a very quick introduction on the CEF and Context Broker, barely, and followed by Stefano De Pamphilus, who's going to talk about Context Broker in a nutshell. The link data section will be presented by Jason Fox. The data models will be handled by Alberto Abella. And last but not least, the performance-related questions will be addressed by Stefan Wiedemann. And the Q&A at the very end will be moderated with all of the speakers, but mainly with Ken Zangelin from, again, Fiverr Foundation. We have a packed agenda, so I suggest we get going. We will try to keep it around 1 hour, but with the question and answers, it might get a little bit more. So just a brief mention on CEF Digital and the actions that we've been undertaking with our action for the past years. Our mission is to increase the interconnection between trans-European networks and helping public administrations and SMEs to allow its citizens to fully benefit from what the digital world has to offer. And we've been doing this by promoting the adoption of common digital standards. We are offering technical support to the different actors and helping them develop secure and interoperable digital services. And also I would say there was a funding mechanism also within the CEF program that allowed funding to projects and contribute to a more connected Europe. This support package as a whole is presented in the form of building blocks. Here you can see all 10 building blocks that we promoted within the CEF program. Today's main highlight is the Context Broker, which is a digital core component that allows the gathering and reuse of context data in real time, with also possibilities of historical data. And as you can see, we have other building blocks that are also highlighted, like the big data test infrastructure, which allows the running data analytics and machine learning and other big data related topics in your content. E-archiving is one of the other data building blocks, which allows the archiving and reuse, if need be, of the used data. I will not go into much detail since our agenda is very tight, but please, I remind our dear audience to visit us on CEF Digital to have more information on any of the above. So mainly the different ways of using the building block is that you have multiple options, whether to buy a compliant interoperable solution from the market, building from scratch your solution, or reusing through the sample software that we make it available through CEF Digital to make sure that the standards that we're promoting within the building blocks are properly implemented into your solution. And whichever path you choose, we will do our utmost to assist you in your journey. And the key benefits of using our solutions, it will allow you a faster and ready to deploy digital solutions, a safer environment, avoiding the vendor lock-in, and being part of a EU compliant and interoperable solution. And also, not to forget that it's also future-proof and there will be always a follow-up. The CEF program is officially ended, but it's in its last courses, but all these actions will of course be continued within the Digital Europe program. We don't have enough information to bring you up to speed on this, but please do follow us on our different channels to get in touch and stay connected with it on that topic. So with that being said, I would like to now invite to our stream Stefano. Hi, Stefano.
Good afternoon.
Oh, good afternoon. The floor is all yours for your section.
Thank you very much, Erbil. Thank you, everybody, for being with us this afternoon. In a very, very nutshell, I would like to tell you something about the Context Broker, CEF Context Broker, in particular about its key elements. So, yes, as we all know, we live in a life where information are important and gravitate around us continuously. This is not only digital, this is also, let's say, our life as human being, in the sense that our senses continuously take information from around, and they allows us to take decision about our next step. And this is what we want to achieve with our smart applications, smart solutions. That is a solution that are able to continuously grab what is around and support in taking decisions, or in sometimes even making decisions because of what is around us. Unfortunately, what happened is that information in ICT terms are often maintained in silos. This is natural in the sense that we have many different organizations providing, making their own business and providing their own information according to their standards, their culture, and their need to support their own, let's say, users. So, and this is what we have to cope with. And also, this is something that we cannot destroy, in the sense that we don't expect that taxation ministry, that they have their own information system, will not have its own, or the public health its own, and so on. So there are good reasons for this, and this is the situation. What we can do is that to understand why we need something different. And this is what the Context Broker is about. So the idea is that Context Broker is a means to enable organization to collect, manage, and share context information. And here the notion, the important notion, is sharing information. And this is done through with three objectives in mind. First of all, managing real-time data. This is, of course, of utmost importance. Why? Because we want to have the latest news in order to take our decision. So I don't care if a bus is already past a bus stop. I need to know that the bus is arriving at the bus stop in a certain way so that I can reach the bus stop on time. Or the second goal is about that we should be able to process, analyze those data. And this is something that should put ourselves, the data that we collect continuously, together with data that we have already collected, so that compare and create knowledge out of that. Because of course, we know something that is happening now, but because of the experience, this is past data, the experience, we can analyze the context and then taking appropriate decision, knowing what normally is happening. The third objective is that all of these shall use standard. So information shall be provided in a standard way, and in a way that this can be further developed and adopted in other environments. So back to this picture, the idea here is that not to destroy or to break the silos, but to open the silos. This means that we are able to gather their data, push them together in a standard layer that we call context information management layer, and from there access to create value on top of. And this is what Context Broker is about. It's about the creation of this layer, and it's about accessing the layer in a bidirectional way. That means updating the data, but also reading the data using standard APIs. To make an example of this, this is what happened beginning of last year when COVID-19 appeared, and a company that is member of the Fire Foundation, they in 5 days create an application able to support the tracing of the spreading of the pandemic, the flu. So, and this was done by grabbing information from different archives or different systems that they, as I said before, have their logic to exist independently, but having put all of them together, this allowed to create a dashboard to understand and trace the expansion of the COVID-19. So in one side, you have the information of the tests done. From another side, you have the access to the composition of the family, if any. In another one, you have the place where the person is working, and so on. So putting all this information allows a better tracing without destroying the silos, but opening the silos. That is even more that CEF Context Broker is a technology that leverage on existing investments. It's not wasting what is there, but is adding value of what is already existing. And this is, in fact, the dashboard created that allows to access, to understand the situation. Of course, in order to implement something correct, this system had the integration with correct access control level, so that people were only reading the data that they have to. So in concluding this my short nutshell overview of Context Broker, Context Broker is a system that allows you to take the data at the right time in a way to organize them, to be able to read and access them from the heterogeneous sources, so that in a normalized way, in a standard way, that the Context Broker leverage on existing investments that are there. Of course, you can do additional one, but this is exactly the case. You do additional, you don't replicate investment that have been already done. And then, as you see from this experience, that only in 5 days, this company created the solution that I showed before. So this simplify the creation of systems that support decisions by even complex organizations. So back to you, and eventually to Jason, and my colleagues now will go more in depth of what the Context Broker does and what to leverage on. Thank you.
Thank you very much, Stefano, for this great presentation. Indeed, now it's my pleasure to announce Jason Fox, which I'll be adding right away. Hi, Jason.
Hi there.
The floor is all yours.
Okay, give me a presentation. Hi, I'm Jason Fox, and work with Stefano at the Fireware Foundation, and I'm going to be talking to you about linked data. So if you could share my presentation rather than share my face, or both, that's fine. Right, this builds on the stuff which Stefano said, in that the interface which is being promoted by CEF is called NGSI LD, and the LD bit is called linked data. It is for linked data, and we'll go into the some examples of how this works. And the whole point is, why do you need to bother? What's the point? Okay, why are we promoting a system like this? Now, if you live in Europe, you realise there's actually 3 different ways in which you can try and push a standard. One of them is the Chinese method, where they say every city in the entirety of China will follow this standard. That doesn't work in Europe with 27, 28, 50 different countries with different authorities and what have you. Another way of doing it is the American way of doing things, which is saying, okay, we'll give it to the highest bidder, whoever can come up with the become a monopoly in the system, then they take the entirety of the pie. Well, that doesn't work in Europe either, because we're here to try and promote competition. But promoting competition in itself does have its own difficulties, so hence on to linked data. Problem is as follows, and can be summarized by definition of Conway's law, in that any organization, and we've got thousands of different authorities, will produce a system which is based under their own communication structure. If, for example, I am a Spanish company creating temperature sensors, it's quite possible that internally within my system, I will give the name of that particular element of context temperatura, because I'm Spanish. If I am doing it in a different place, I'll use different names, different structures. So the data which you hold within your context, your context will differ, even if we can release it from the silos. So I will have a context broker, you will have a context broker, but we need to be able to make sure our data communicates effectively. So how can we get around this issue? Well, here's 2 really illustrative examples of the barriers to data exchange. On the right is quite an obvious one, is that if you have a national border, if you are on the border of France and Italy, and you want to encourage tourists to come over from Italy to France, to Menton, or vice versa, then you need to be able to extract information from other local authorities who are potentially using different language to you, potentially using different data models to you. But you need to be able to extract the information to be able to get hold of useful stuff. Similarly, borders can actually be very, very unclear to the average person walking down the street. I could be a Dutch local authority, and I'm trying to reduce traffic congestion. So I need to know, how many spaces are there in the car park. It could be that there's a national authority border just down the road. So I couldn't tell that actually the car park in Augustplatz is actually got spaces, whereas mine is completely full. I want to be able to collate data which has been taken from different authorities to actually get hold of an insight through my context layer to be able to understand what's going on. But their data could be different to my data. And this is where linked data gets around this issue. Linked data, it's an extension, in this particular case, it was an extension of JSON. All of the NGSI interface is an extension of already existing ideas. It's nothing new. So JSON and JSON LD are a data format, and the LD is effectively just this additional at context element. It does more than just clog up your data, but that's what it does. So what JSON already is it's lightweight, it's easy to read, you can understand it, and it's using the names which I prefer. I mean, I prefer to have names like name or born or spouse rather than anything else. However, it's structured in such a way that I can have a meaningful name which can be shared across multiple systems. It can be I can also navigate from one part of the data to another element of the data, because these names which we've got here are insufficient to be able to define something. Name is not good enough. I'll show you an example. I have a colleague at the Fireware Foundation. He's called Harpreet Singh. Harpreet Singh is our blockchain and smart cities expert. So here we have 2 guys called Harpreet Singh. both of whom are active on LinkedIn, both of whom are dealing with smart cities, both of whom are dealing with blockchain. Which one's which? How would you distinguish between the Fireware Foundation's Harpreet and this other Harpreet? In fact, talking to Harpreet, he said, I think there were 4 guys called Harpreet in his class, so it's not, it's quite a common name. Well, the actual answer is quite simple. All you need to do is to assign a URL to whoever you're talking about. Now, I don't want to talk to https linkedin.com in sing blah 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 every single time I'm referring to that element within my application. However, when I'm publishing data to be consumed by others, I can offer this as a really rather explicit format for being able to say, this is what we're talking about. So when you're talking about a name, it would be, say, defined from the friend-of-friend format, or would be defined from the schema.org format. And that would say, okay, I know precisely what that is. A name is actually the name of a person rather than, say, a login name or a nickname or something completely different. So moving on from JSON LD, which is the basis, we can actually move on to proper NGSI LD, which is the basis of the CEF building block. And NGSI LD is an evolution of, again, basic systems which have been around for about 20 years. I think the original NGSI specification, the earliest ones I've seen, is about 2002. It's REST with a well-defined JSON format on it, and it's you're able to extend this to be able to get information across. So you can see there's very little difference between the payload which I was showing for JSON and the payload which I'm showing for NGSI LD. And this is deliberate because all NGSI LD payloads are indeed valid JSON LD. The difference it's got, and you can see this in here, is that you have properties and relationships. It is explicitly saying, I am this particular person entity has got a property of name, which would be based on my context, would be a, say, schema.org name, and the name of that person is John Lennon. Or similarly, this particular person entity has got a relationship to another object within the system, and you can use that to navigate the graph. It's important to remember that all this information, the reason why you bother with all this structure, is to make sure that it is machine readable by random third parties. The classic example of linked data, if you ever go onto a search engine and it gives you a star rating for a product you're looking up, it's because embedded within that page is a little bit of linked data which says, yes, this is the star rating, and whatever I happen to call it within my system, it's actually this particular long URL is what we're dealing with. A little bit on how you structure stuff in NGSI LD. As you can see, it's a evolution of the previous NGSI v2 version. You can see there's not that much difference between the two. The main point is that your types for your attributes, which are the bits of context which are likely to change, are now always going to be either property, geoproperty, or relationship. And you've got this extra at context somewhere in the payload. You can either place it within the body of the entity, which is creating an entity, obviously, but you could also place it as a link header, which is associating additional information which can be downloaded from somewhere publicly. I need to publicly state, okay, what I actually mean by building, for example, what I actually mean by address, all has to be held publicly within my context data. The extension of this is that the model can have properties, and then it can have properties of those properties, or relationships of those properties, or properties of properties of properties. So you can actually drill down to get additional metadata based on a series of 5 or 6 definitions. Property, relationship, value, and what have you are all defined within the core context of NGS-ILD, and then thereafter you can use this information to be able to navigate around the system. You'll be hearing a lot more about data models from my colleague Alberto later on this afternoon, and you can see that you can have for any entity which is something out there in the real world, it will have some identifier of a type, it will have some unique ID within the system. They will be URNs typically, and then it will have some properties, what's actually going on in the thing, and potentially it will have metadata and so on and so forth. But you can see that this can be expanded further on, so you can get a full understanding about what's going on. When you are retrieving the information, you may alter which context you're actually using, and therefore you may get additional attributes or different attributes depending on how you're passing it. So you could, for example, if I'm saying that this is an attribute called address, it could be translated to ADDR within your system using a standard JSON-LD expansion compaction operation. The example highlighted on the screen would be to say expand an enumeration, which would be to say that this particular category is a commercial category. That's not currently fully specified within the specification, but it's the sort of thing which is getting in there fairly soon. There are a few well-defined elements. Obviously, context elements tend to have some, because they're real world things, tend to have a certain place within the world, and these are defined within the core context. The core context cannot be overridden. So instead of using, say, geocoordinate or located at or Standort for where you are, it would always, in an NGS-ILD system, be location, and that would always map to an NGS-ILD location using that URI as defined in the core context. This means that you can you can confidently do things like geofencing, knowing what the default is. Another example on the limited number of things which are defined within NGS-ILD, unit code. You know that you're talking about meters rather than centimeters or inches or whatever, because that has a well-known value. It is possible to override these, but that means they wouldn't actually be NGSI anymore. It would just be JSON-LD. Similarly, you can do expansions of URLs within your personal context. So you can see that, for example, my category is a fireware category, which is a URI fireware org data models hash category internally, so that you can, when you define your mappings, which is what your short names are to your long names, you can actually avoid creating too much information, too much weight in your payloads. Obviously, if I have one of these, it needs to be public, and you can use a different one. Someone else can download this and use other information. Now, I'm trying to keep this relatively short, so plenty of other people have said really useful stuff on the internet already. It is assumed that you can understand more about the fundamentals of JSON-LD, like the fundamentals of REST, which is what the verbs for pushing the data to and from the context broker would be, or the fundamentals of NGSI. There are plenty of links, like information on this. There are tutorials on this, and plenty of standard data models you can use thereafter. So that is my particular section. If you want to find out what my URL is, it's on the screen right now, and then I can pass you back to the other presenters for this afternoon.
Thank you very much, Jason. Thank you. Perfect timing as well. So without further ado, I would like to add Alberto to the stream. Hi,
Okay.
Alberto. Can you hear?
Hi. Yes, I can hear you. Hopefully you can hear me
Yes,
as well.
perfectly
Another
fine.
presentation, please.
Yes, I
help
will
me on that.
share it as soon as possible. I'm adding you. Voila.
We are waiting. So my name is Alberto Bella. I'm working for Firewall Foundation as a data modeling expert, and we are talking right now just a bit about how to convert the data into information. And in order to do that, please go for the next. What we need to do is just to share the same concept between those who are interchanging information, as Stefano mentioned into his presentation. The silos will be living with our organization, but it doesn't mean that it cannot be open. And therefore, in order to be open, we need to share some of the concepts that we have between one participants in the transaction and the others. The agenda for this small explanation is I'm going to explain the Smart Data Models Initiative, which is an agile standardization move, how to use it, and eventually, if you want to contribute, how to do it, and the next steps of this initiative, which is alive and kicking. And if we can go for the next slide. So the first, the principles of this initiative is that what you get there is free in terms of price and free in terms of freedom. So you can do whatever you want, where you need, and it's for all and forever. Okay. It's an agile standardization initiative, which means that we do not have, let's say, standard review periods like classic standardization, in which you have to wait 2-3 years for the review. We can do a review twice a week or twice a month or one in a year. So it is not a big deal for us. It's an initiative which is being supported by 3 organizations, one based in America, which is TM Forum, another which is based in India, which is IUDX, which is the Association for Data Interchange in between cities in India, and the Firewall Foundation. Okay, it's a community site in the sense that the data models here are collectively contributed. So it's not we are not creating data models. We are just taking existing data models which are being used and put, let's say, in a way that can be used for many people, anybody, ideally. Another point that we have is that we have a single source of truth for the definition. So the technical definition and the document definition is the same very document, which is a JSON schema. And additionally, we provide as mandatory examples of this definition and how this definition is implemented into several examples. This single source of truth allows us to create automatically basically most of the documentation that you are going to need for understanding this model. So, and we generate currently 3 languages for every document, and we are on the path of the 4th language. So currently English is the first language, but there is also for Spanish and for French, and German is on testing, and will expect to expand these translations as soon as we can, because it's possible. When you have automated things, this kind of things is possible. All these data models are structured into domains, and these domains refers to industrial sectors, and into subjects. Subjects are groups of data models which are with a similar topic. And what we do is to keep the coherence and the consistency across the different domains, so that the temperature, as Jason mentioned, means the same and is the same type of data here in the weather domain or there in the environment. Okay, we can skip to the next. Yes, Erbil, could we go to the next slide? Oh, thank you very much. What you see here is the structure. The structure has 2 levels. The domains that you see in the main level, so smart water, smart cities, smart agri-food, you have, because there were no room for that, smart aeronautics, smart health, which is emerging. And all these domains can have below several subjects. But on the other hand, these subjects could also belong to several domains. In order to provide you with an example, the weather is quite relevant for the smart cities, but it's also relevant for smart water, or for a smart environment, or for smart destinations. Okay, and there is another 2 repositories that I want to explain to you. which is the harmonization and the incubator. These repositories are allocated into GitHub and are publicly available, so anybody can see it, and anybody, once requested, can contribute to them. The harmonization are for those data models which are coming from adopting regulations. So our goal is not to create anything, but to adopt things that are already working and are open, of course. And we put into this repository those data models which are missing, let's say some example or documentation or whatever. And the incubator repository is the most active repository in which many people is creating the data models, okay, and helping each other. And we provide also support there just in order to get new data models into the repository. And in this case, currently we are working with the integration with the European Open Data Portal by the standard DCAT AP, or we have for machine learning models for defining them, or we have some others for robotics, or we have for water management. There's plenty of things there. I recommend you to go to the GitHub and to look for the incubator repository of the Smart Data Models Initiative. You will find out plenty of things. We can go for the next. What can you do for using them? What you can do is to use some of the services which are available. The first and possibly the most relevant service is to look for something which can be useful for you. There is a search tool which is currently compiling to 12,600 elements, in which you can look for anything that you wish. You can look for the property name. You can look for the data model if it is an entity that you are expecting. Imagine that you want to look for a parking. Is there a data model for parking? The answer is yes, I know, but you can look there. Or is there a parking in any of the definitions of these 12,000 data models? Yes, you can go to the description box, put parking, and then you find out where is there any property describing something of parking, or eventually you can look for the type of data that you have inside, because for whatever reason you only want to need integers, and then you can check for all the properties which are integer. Or maybe you can look for the units, so I need something which is measured in kilowatts, and then you can look for it. Or all the other options. Okay, this is possibly the first. The second is that you can create an example. Imagine that you find out through this tool one data model which looks nice for the use. Maybe if you want to use it, you need to see some examples. Although there are some static examples which are with every data model, then you can click in this link, and you can create an example, and every time you click, a new example is generated. So you can populate your database with these examples just for testing purposes. There is a main site, which is smartdatamodels.org, in which you can see everything which is happening into this initiative, all the contributions, all the new data models, all the updates, anything is mentioned there. If you don't want to visit a web page regularly, you can go to the Twitter account Smart Data Models, and you can find everything in a very compressed way and with a link. Or eventually you can subscribe. If you visit, there is a subscribe option in which you can subscribe to the different domains that we are working with. If you are only interested in cities, you can click on cities, or in water, or in whatever. You can subscribe, and once a week on Fridays, you get a mail with 3, 4, 5 new things. Okay, and the last service that we provide for the users are the dissemination. So if you are using some of these data models, we offer a file to get close to every data model, which is called adopters.yaml. And in this adopters.yaml, you can put, I'm this project, I'm using this data model from this date. You can put a contact mail if you wish, or just all of the fields here are optional, and therefore you can put wherever you want. Okay, just for dissemination purposes. And now let's move into what can you do if you want to contribute with new data models. Okay, first of all, there is 2 elements, as I've mentioned, which are mandatory. First is the JSON schema, in which, remember, is the single source of truth. So the description of the of the properties are already there, and examples of payloads. So it's not accepted a data model which has not an example, and these examples belongs to something which is actually working. So because our data models are based on actual use and not in, sorry, because I'm an academic as well, in an academic design. So has to be tested on real cases. There is also a file which is voluntary to be filled, contributors.yaml, in which if you are the contributor, you can get credit for being, or of course you can if you don't want credit, you can omit it. And the file adopters.yaml, which is also if you want to provide dissemination for use. And all these documents that you see below in the point 2 are automatically generated. So a README describing the data model, where to find the links, where to find the descriptions, the specifications in different languages. A model.yaml, which is a YAML version of the schema, which is more readable, just for the technical guys, or a version which is close to an Open API 3.0 for seeing the specification in another format, or CSV exports, because our goal is not only to be compatible with NGSILD standard, but also with other standards that can get connected to the same data models, and therefore get a higher interoperability, even if you are not sharing the platform. And of course, there is other file together, which is the license, which is allowing you to share this data model. And of course, the specification, you see 3 here, which are the examples. And on the right, what you see is an automatic generated specification with a list of properties, the definitions, the main description of the data model, which definitions are required, and so on. Can we go to the next? And these are the services for the contributors. You can validate the examples that you are providing against the data model that you are providing. You can check the documentation that you are submitting together in this JSON schema. You can be one of the authors. You see on the right that this is an example of how they are created. There is a contribution manual that you can review, and it's compulsory to follow in order to get validated. You can check your schema, definitely, or even if you are not familiar with JSON schema, which is something out of your knowledge, you can create a drafted schema with a Google spreadsheet. You just put the name of the properties, the data type, the description, and there is a tool which helps you to create a very first version. And of course, these 2 services, which I've mentioned before, which is harmonization and incubated. And could we go for the next? And what are the next steps? So we keep on promoting the interoperability by extending the exports with SQL, an example, or others that could happen. Extending the steering board. Currently, I've mentioned that there are 3 organizations here, but we are open to some others, and there are conversations with some of them. We keep on translating regulations. We have translated the Energy Common Information Model and some of the schema.org, but we are going to keep on doing with tourist regulations, and some others will be soon available, and for mobility. And of course, we have just launched a survey to the users in order to understand what is better for them, what is more valuable, and to align our efforts according to the needs, and of course increase these 12,600 searchable elements in these domains which I mentioned, because all of them are showing now a high rate of activity in terms of increasing data models like energy, water, mobility, agri-food, smart cities, health, buildings, and some others. And I guess that it was everything that I wanted to mention. Thank you very much. And I guess that there is a Q&A session, and I open to answer all the questions that you need. Thank you very much.
Thank you very much, Alberto. I will, without further ado, be running perfectly on time, actually. I will right now add Stefan to the loop. Hi, Stefan. Can you hear us?
Hello, Erbil. Yes.
Yes, perfect. The floor is...
Can you hear me? Yes.
Yes, we can hear you.
Okay.
The floor is all yours.
Can you show my screen? Okay, yes, thank you. So, hello, my name is Stefan Wiedemann, and I'm an architect at the FIRA Foundation. In the last months, I was building scalable production-grade deployment scripts for running various FIRA components, especially the Context Broker. Besides providing those deployment scripts, we also wanted to provide proof for the ability to scale and publish reliable numbers for the scaling ability. We solved this with a combination of Helm charts, leveraging on Kubernetes' ability to scale microservices, and some improvements on the Context Broker to get it more cloud-ready. To prove those numbers, we used multiple open source tools for testing and publishing the results. In the next 15 minutes, I want to take a closer look on how to get started when building a scalable Context Broker deployment, and an overview on our solution and how it can help you. The first task when starting to build a scalable deployment is that you should know your use case. Most of the time in software development, we have to handle trade-offs. If you optimize one thing, it might degrade another functionality, or it at least does not scale in the same way. But in order to have every functionality at the same high level of performance, you probably might need to oversize the installation in a way that it makes it expensive and very inefficient to run. To prevent oversizing, I would recommend to start with thinking about the following points. Depending on your concrete use case, there might be more, but I think those three are more or less common in every use case. As you probably might know, the NGSI LD API, and therefore also our Context Broker, allows a wide variety of retrieval and querying operations and different methods to write data to it. Because of that, you should check if your focus is on multiple parallel high-frequent updates, or if you require a lot of parallel retrieval requests. Also, the type of those requests is quite important. If your typical request will be a very complex query, you might put more pressure on the database, while if you have a lot of parallel entity retrievals, the broker's connection handling is the more limiting factor. It's clear that we will have most of the time a mixture of all of this, but finding the focus and probably the first functionality to reach the limits will help us to get the right focus for the deployments. The next important point to look at is the kind of updates. The API allows different ways of it. So, for example, updating a single entity, update single attributes, or updating multiple entities in one batch. If your use case requires, for example, a lot of parallel updates of single entities or attributes, the configuration of connection pools for the broker and the connected databases are very important. While if you have fewer but bigger batch updates, you put more pressure on the broker's memory. Another important feature to keep in mind when optimizing is the usage of subscriptions and notifications. Notifications are quite important and powerful feature of the NGSI LD API, but they are also one that can easily harm the performance of the broker if you not correctly use and configure them. So first of all, you should check if you need them at all. If not, you can skip this section. If they are used, it's important to know how the typical subscription will look like. If there are a lot of subscribers that only receive some data, the connection pool configuration will be different than if you have only a couple of subscribers. Like, for example, if you use the Context Broker in a deployment with additional components like Quantum Leap or Cosmos. Orion provides very fine-grained options for configuring those connection pools, and they can make a huge difference for a given scenario. I will not concentrate too much on those options today, but I recommend to take a close look on the documentation for them when you optimize your broker's deployment. The last important point for the subscription is that you should be aware of the impact that a subscriber's performance has on the broker. If the subscribers are slow or unstable, they can also slow down the broker itself. In such cases, it might make sense to use some kind of circuit breaker on your cluster to allow fail-fast for the notifications, or put a more stable and performant intermediate component like an MQTT broker in front of your subscribers and use MQTT subscriptions. Okay, so now that we know how our use case will look like, we can start with the actual optimization. In order to do that, we not only need to take care about our broker, but we also need to know our underlying infrastructure. The infrastructure should be able to scale in the required way and also support managing a highly scaled cluster, especially when we have a peak situation. Fulfilling such requirements will need a high degree of automation. Therefore, we choose Kubernetes as the recommended orchestration tool for installations of FIRA components. Kubernetes was originally designed by Google and is now an open source project maintained by the Cloud Native Computing Foundation. Therefore, Kubernetes can run on bare metal, but it's also offered as a managed service by most of the cloud providers. It provides us an abstraction layer so that we can use the same deployment scripts in different environments. Besides that, it has functionality for automatic up and down scaling, and thus can help us with building the cluster in a very cost-efficient way. Since every deployment of the broker needs some degree of individual configuration, we decided to use Helm charts for the deployment script. Helm is another CNCF project and provides a templating mechanism for the Kubernetes recipes. You can find the chart for the Orion broker at the link mentioned here. Beside those deployment scripts, I would recommend putting some focus on the operational tooling. Running and being able to react on a cluster in high-load scenarios requires proper tooling for logging, monitoring, and alerting. Our own clusters are built on OpenShift to provide those functionality, but there are also other options like Thanos, Prometheus, FluentD, and similar things that can be used in Kubernetes clusters. Additionally, if you run your cluster on a certain cloud provider or one of the hyperscalers, they also often already provide some managed tooling to handle those aspects. After analyzing the use case and setting up the infrastructure and the broker itself, we need to test all the assumptions and decisions that we made for our deployment. In order to do that, we implemented a set of load tests that can be run against any implementation of the NGS ILD or also the NGS v2 API, and allow to test if the installation is able to handle the planned load and find the boundaries of the installation. The tests are built based on the Gatling framework. Gatling is an open source framework for load testing that supports a high degree of parallelism and offers a domain-specific language to implement relatively easy-to-read tests in Scala. It provides a report that allows close analysis of the test runs and a configuration mechanism to run scenarios in different sizes. The reports are provided in HTML. They look similar like the ones that you can see on the bottom of this slide. Our test implementations are fully available on GitHub, and they can be executed either via Maven or inside a Kubernetes cluster with a Helm chart. For simulating high-load scenarios, we recommend running them via Kubernetes. The Gatling scenarios then will automatically be scaled out over multiple pods by the Helm chart and report to a central instance inside the cluster that aggregates the individual reports and finally provides the combined report. Beside that, if the tests are run inside the cluster, it also takes away the network of the load generator as a potential bottleneck. But you should be aware that in a production environment, your external load balancer and the ingress controllers also need to be able to handle the load. The tests will only go through internal load balancing if you run them inside the same cluster. Beside the test implementation itself, in our Git repo, we also offer reports of test runs that we already executed. The tests were run on different sizes and configurations of the clusters and should provide a reference for choosing the right size for your cluster. All reports include a detailed description on the configuration of the infrastructure and the charts that we use for Orion, for the Orion Context Broker and the MongoDB behind the Orion. We provide the configuration for the database because the Context Broker is tightly coupled to its database, and therefore both need to be scaled to prevent Mongo becoming the bottleneck. I will now give you a short walk through the GitHub repository where we provide the load tests and the deployment scripts. You can find the repository under the Fiverr Foundation in GitHub. I provide the link on one of the slides. At the first page of the repository, you will find an overview for the whole framework. And as already mentioned, you can run the tests via Maven or via Helm. You can find all the information to do this here. Since all of those tests are normal Gatling implementations, all other usual ways to run a Gatling test can also be used. I would recommend taking a look on the Gatling documentation if the described options do not fit your needs. After this, you can find a detailed description of all the common use cases for the NGSI LPI that we already implemented. If you have discovered more specific scenarios in your use case analysis, it might make sense to implement additional tests that fit better. We can take a look at the code. This is how a usual scenario will look like. we provide some templating, some already implemented methods that can be used or recombined so that you can easily create new scenarios, or if there's some more complex requirement for you, you can also implement new methods. The first set of tests that we provide here focuses on the write operations. So we have a test that writes single entity updates, and we have also one for the batch updates. You can configure the number of entities to be created, and you can also configure stuff like the batch size. The next set that we provide is mostly focusing on entity retrieval and querying. We also have, again, different types of queries provided in these tests. Since we need data sets to query on, a sample scenario is always created at the start of every test, and it is cleaned up afterwards. You can find out more how data set looks like in the Docker in the documents folder. It's linked inside the documentation here. Beside that, all tests support a pre-filled parameter that can be used to create a certain number of entities to be put into the database before the test starts. You should be aware that this can drastically increase the runtime of the test itself. The third test of group of tests is kind of an extension to the update tests. It focuses mostly on notification. It will generate the same Gatling reports as the other tests, but also provide some measurements on the duration it takes from an update generated at client side until it's received by the subscriber. In order to take out the subscriber as a bottleneck, we use Telegraph and InfluxDB in the Kubernetes tests. As shown here, the duration is measured via a creation timestamp at the Gatling client, and then a reception timestamp when the notification is received at Telegraph. So we did go through the whole broker, and you can analyze the data later in the Grafana. As advertised, we also provide the results of the load tests that we already run. They are linked here. Right now, we already tested installations of 3 different sizes, focusing only on the Orient Context Broker and the connected MongoDB. We call them tiny, small, and mid, sizing from 9 CPUs and 22 GB RAM at tiny, up to 68 CPUs and 176 GB RAM for mid. Be aware that the complete production cluster will be bigger, since the resources for load testing, monitoring, and alerting, and also the Kubernetes master nodes are not included here. But now let's take a look at the concrete setup. I would go for tiny. It starts with a short description of what this instance is capable of doing. As you can see here, with only 1 CPU, the broker is able to handle up to 1,300 or 1,500 updates per second at the NGSI LD endpoint, and up to 2,000 requests per second on retrieval. It is able to even handle more for the V2 endpoints, which comes mostly because the computation overhead for the linked data context is not required here. We linked detailed reports below here for every test that you have seen before. I would take a short look on the entity update with subscriptions. On top, you can find a report about the average request timings for all requests. Below, there is a very detailed report on every step of the test, and all information you can imagine for this. Don't get confused with the notion of user here. This is because Gatling is coming from a background of testing web pages. So users in our scenario corresponds to entities. The most interesting chart for finding the boundaries of our instance is the last one, which shows the number of responses per second. You will see that in the front and in the end of the graph, you have lower numbers. This is because we have the startup phase and the cleanup phase included here. The interesting part is the plateau in the middle, where we can see that we reach around something around 850 up to 900 requests per second for this scenario. Beside this Gatling report, we also provide an image of the Grafana chart because we did measure the notification latency here. As you can see, The mean latency of a notification for this scenario is 1.3 seconds. This is not an interactive chart because we need a running InfluxDB and Grafana for it. So if you need more information, you probably should rerun it and analyze deeper yourself. If you have higher load scenarios, I would recommend taking a look at the small and the mid report that you can find here. The mid report is able to serve up to 10,000 updates per second for the NGSI-LD endpoint. We also observed nearly linear scaling for our instances. In addition to test results, we also provide information on how to reach those results. You can find the description of each environment below here. As already mentioned, we are using OpenShift. You also find the type of machines that we did use. Below, you can find the required Helm commands and optimizations that we did apply on the database to reach those numbers so that you can install the whole system yourself. All the configuration files are provided in the config folder in the format of a Helm value file, as you can see here. Yeah, I hope this will give you a good starting point for your broker installation. I forgot to prepare a page with my email, but you can easily find me in all of the linked GitHub repositories. So thank you for listening.
Thank you very much, Stefan. This concludes the presentation part of our event. I will just take this opportunity to add everyone into the loop for the Q&A section, and also he was one of the main contributors in the preparation of this. I will also introduce Ken. Hi, everybody can hear me fine?
Yes.
Yes, perfect.
Yes.
So before we move on with the Q&A, and I think I saw one question that was addressed to our speakers. There is a question regarding continuation of the CEF program and the future of the building blocks. As stated previously, there is a commitment from the Commission's part to sustain the actions, which will be handled by the Digital Europe program. But at this stage, I don't have much more details, but there is an existing commitment from the side of the Commission. So regarding anything that's a future for the future investments, everything looks safe for now. And as soon as we know more, of course, our audience will be the very first ones to know. I've seen, allow me to share the question that was asked. It should be on screen right now.
Erbil, can I add something to the first question, to the first answer?
Yes.
I can only talk, I mean, I only answer to the context broker, but I mean, it's open source. You can find the entire implementation on GitHub. So even if we would stop supporting it, which we will not, you can always find an engineer and have him look at it. I mean, it's all there, open source. So it will never ever disappear.
Very valid point. Thank you. Thank you, Ken.
Mm-hmm.
For the question that we have at hand, I think, Alberto, you were...
Yes, easy answer. Yes, I didn't get into the details. So every data model that is in the Smart Data Models Initiative, you can use all of them, part of them, or you can extend for your own purpose. So there's no problem on you for doing that. What we do, once if you want to, this is just for use. In order to contribute it, if this data model is already in a use case, what we do is to help you on some generalization, because sometimes you consider that to having 2 silos in a farm is enough, and we explain to the contributor, oh, those two silos is good for you, but maybe there's a farm with 3, 4, 5, or 100 silos. Then we change this approach. Instead of having just 1, 2 single elements, to have any number of these elements. And with this and some other things, we transform slightly what is contributed just to make it usable for everybody. And the other point that we do is that it's quite common that the people try to say, oh, this property should be mandatory, and we strongly suggest for use cases like yours, it's quite likely that it has to be mandatory, but you cannot know to what extent this data model will be useful. And therefore, the less mandatory properties that you have, the better. And in fact, basically just the ID and type used to be the mandatory properties and few more. So you can use every part that you need from a data model, which really helps you on achieving the interoperability between the systems or your clients or whatever.
Thank you very much for this answer. I unfortunately don't see much more question coming right away, aside from if the slides will be shared, which it will be in the event page as shared from my colleague Regina. In the meantime, we would like to address a couple of poll questions to our audience.
About the data models, I would like also to add something.
Oh, please, sorry. Apologies, Stefan.
Said very nicely, but yes, the usefulness of data model is about sharing, as we said. So the more they are stable, the better, of course. So that is the key message that we have to give. Again, is as very well Alberto said during also his presentation, is the key to open the silos. So it's the great tool to do that, and the more application, the more people use the same data model, the more that application can be ported from an environment to another one, and the more there is sharing. Basically, yeah, this. Thank you.
Thank you. Thank you. So I had taken this during this intervention to launch also the poll question that was addressed, and I know that we have way more audience members available, so please don't be shy. It's already very nice to see that we have 4 replies that actually tells us that this type of technical webinars can be also presented in a deeper way, which is our also ultimate wish, and I'm hopeful that this number will grow. Thank you very much for the new vote that was added. So if, as said previously, if you're following us from YouTube, if you want to participate in the poll, you can use the Slido page with the code that's visible on the left. Your input is invaluable, so we're very much looking forward to collect it. We'll give just one more minute if there are more who's willing to participate, but I think we can conclude that we can try and organize in the near future a more in-depth webinar to discuss about the topics that were discussed today into more detail. That's very encouraging indeed. I'm just checking some of the... Okay. Thank you for the new addition. I will just move on to the next question.
Oh my God. And that's who's the winner?
Let's see. About our presenter.
Told you.
One.
Okay, so far it's confirmed. Jason. Okay, I think it's going to be a close battle.
Like Eurovision, the contest.
I would like to remind our audience that Stefan was very key in the presentation of all this, and that in the next webinars, I'm hopeful that he will also be joining us for going into much detail. But thank you, we're getting enough numbers, and I think it's going to be more difficult for us to read on how to interpret the results if everything ends up in the dead middle.
It's challenging. This.
Yes, indeed. But right now, I think Jason is
This
bringing home
okay.
the cake.
Okay, congratulations.
Yes.
The problem is, of course, is the stuff which I was doing, the stuff which Alberto were doing, are very much linked, because you want to have a linked data model which works with smart data models. So maybe the pair of us could actually turn up and have 50-50 each.
Yeah. Of course. All right. So I will just go ahead with the last poll question, which is also invaluable for us to better shape our content for the upcoming webinars. It's an open question, so please feel free to type in a couple of words on the things that you'd like to go into more detail in our future events. Okay, so far I don't see, and I will take this opportunity to check if there are other questions in the meantime. No. Other CEF building blocks. On a SMO level, I'm very happy to announce you that we have regularly organized meetings. If you can follow us on CEF Digital to check our events page, you will be seeing many other building blocks and webinars around them as well. Okay, interoperability using EU core vocabularies. Interesting. On the last one, setting up minimal production grade context broker environment. Is there anything that we can address to that?
So I already can recommend the mentioned tiny environment. So this is, I think you won't get much smaller than that and still being stable. Question is if you need more information about additional components. So our setup focuses on the context broker and the database, but maybe we can concentrate more on the surrounding tooling to maintain such a cluster if there is interest for such thing. That's something we do not have yet.
Okay.
There's one thing to add to that, is that there are various fireware tutorials bouncing around which are there for instructional purposes only, and the architecture is completely wrong if you want to have a proper production grade environment. So don't follow the tutorials when you are trying to do a proper environment. Follow the Helm charts. It's even mentioned in the various lumps of code. Don't do this, but this is just another warning. Go over there. Don't come over here.
Okay. I suggest we give just one more extra minute to check if there are any other questions or any responses for the poll. But if not, I would also like to remind our users to fill in the satisfaction survey that was posted in the chat. It will be very important for us, and we thank you in advance for it. And yeah, I think we've been just a little bit over schedule, but this was due to the Q&A not being necessarily part of the agenda. But thanks, I would like also to thank our speakers who not only with the quality content, but they were also amazingly accurate on their timings. We kept the program as it should be. I see that there is also a request to use real examples on using CEF building blocks and use cases. Maybe we can try and give an angle to the technical webinar we'll organize, also practical use cases and showing how things were tackled. It could be an interesting topic and angle to it. So that being said, I would like to thank everybody who participated, and to our audience also who was following us on Slido. And I will call this meeting to an end. I'm removing our participants one by one. Thank you very much for your time. Please do follow us on CEF Digital and different social media addresses that we have, which I will be displaying right after I remove myself from it. You will also, the registrations will be followed up by a stay in touch form. If you need more information, please do fill it so, and we will most certainly get back in touch with you at the earliest convenience. Thank you very much. Have a lovely day and stay safe. Bye-bye.